Hello, all. So what are we going to be working on today? Well, today we're going to be working on finding a limit that involves a bit of algebraic manipulation involving a square root. So before we get started, I want to start us off with a little trick that we're going to use during this problem, okay? My trick is that if I take a plus b times a minus b, I will get a squared minus b squared. All right, let's make sure that's true. We don't want to just use the trick without making sure it's true. Let's go ahead and FOIL. I'll have a times a, which is a squared, a times negative b, which is a negative a times b, then a positive b times a, which you could put ba, but I'm going to write it as ab just so it's clear that the middle terms will simplify, and then a b times a negative b will be a minus b squared, and I see that, aha, I have a minus ab plus ab, those will disappear, and I'll just be left with a squared minus b squared. Now this is just going to make our job a little bit easier as we're solving this example. Okay, so we're going to keep this in mind, my trick here. Okay, so let's determine the limit as x approaches 2 of the square root of x plus 7 minus 3 all over x squared minus 4. Now, this one isn't super challenging. You could have a more challenging example that's similar to this, but we just want to make sure we know what's going on, right? Let's start a little simpler, and then if we need to tackle something more difficult, we will. Now, the first thing that we should do is to go ahead and let x approach 2 and see what happens. Because if we do get a defined answer, right, then that is the limit. We will have determined the limit. So I'm going to do this in a different color. And I'm going to let x approach 2, meaning I'm just going to plug in x equal to 2 and see what happens. So I'll have a 2 plus 7 underneath the root minus 3, and then a 2 squared minus 4. And if I simplify, that means I'll get a 3 minus 3 in the numerator and a 4 minus 4 in the denominator. And so I see that I get a 0 over 0. I'm going to put a frowny face. This isn't necessarily a bad thing, even though I put a frowny face. It just means I haven't found the answer. So this is one of our indeterminate forms. Now, maybe you haven't quite talked about those yet. If not, let's just give it an easy explanation. When I say it's an indeterminate form, what I mean is we have not determined the answer yet. We need to do a little bit more work to find our answer. And so I'm going to erase this and kind of say, well, that didn't work. So let's forget about that. That means I'm going to have to do a little bit more work in here with this expression before I let x approach 2. And now because we got 0 over 0, I'm thinking that there's something in the numerator and the denominator that we could simplify. And I'm going to use this trick. Ready? My trick is that I'm going to multiply this by 1. I'm allowed to do that, right? That doesn't change anything. I can multiply it by 1 and it won't change the expression inside the parentheses. Similarly to how I could add 0, right? I could put plus 0 and that wouldn't actually change anything. So maybe I'm manipulating the expression, but I'm not actually changing it. But we're going to be even trickier. I don't actually want to just put times 1. I'm going to multiply by the same expression that has the root, so square root of x plus 7 with the 3, except I'm going to change the sign in between the root and the constant. So I'm going to make it a plus. What you're going to find is that this is going to do away with that square root and fix some of our problems for us. Now, remember I said I wanted to multiply by 1? So think of it like this. I can multiply by 1. That would be the same thing as multiplying by, say, 2 over 2, right? 2 over 2 is equal to 1. I'm going to use this idea and just put the same thing in the denominator. By doing so, all I have done is multiplied my expression times 1. So perfectly allowed. I haven't actually changed anything in my expression. Okay. Now we need to do a little bit of algebra. So in the denominator here, where I have one expression that doesn't have a root, and then I have this other expression that does have a root. I'm just gonna leave it alone for now. We may have to do something later, but for now, just leave it alone. Just gonna leave them as multiplied sets of parentheses. Now up here in the numerator, where both of my expressions have a square root, I'm going to FOIL, multiply it out. Okay, now notice I could use my trick here because I have a square root of x plus 7 and then a 3. One has a minus and one has a plus, right? So it's actually just this trick that I talked about at the beginning. So I could do the first entity squared minus the second entity squared. And I know this is going to add a little extra time and it may bore you a little bit, but I'm actually going to solve it both ways just so you see you get the same thing. So on this side, I'm going to FOIL. On this side, I'm going to use the trick so that you see that there's no issue with using our trick. If you use it, you'll still get the same answer and it's not a problem. Okay, so let's actually FOIL. Better leave a little more room. The foiling will take a little more space. Let's FOIL on the left. So I'm going to keep my limit as x approaches 2. You can keep parentheses around the expression if you want, but just keep in mind, I'm taking the limit on this whole expression, right? So I don't like to have to write the parentheses a bunch of times. So let's FOIL the numerator. So I will have a square root of x plus 7 times a square root of x plus 7. Then I'll have a plus 3 times square root of x plus 7. Then I'll have a minus 3 times square root of x plus 7. And then a minus 3 times plus 3, so a minus 9. And then I said leave that denominator alone for now. Maybe we'll have to do something with it later, but we don't want to get ahead of ourselves. We certainly don't want to FOIL the denominator. All right, now let's simplify. Okay, so I have a square root of x plus 7 times a square root of x plus 7. When I multiply them, that'll just leave me with a regular old x plus 7. Then I have a plus 3 root x plus 7 minus 3 root x plus 7. So those will disappear. And I'll just be left with a minus 9. And then I told you to leave the denominator alone. Leave them alone for now. Okay. Now, using the trick, I guess it doesn't actually eliminate a step necessarily of writing, but it just makes things a little bit faster. It makes it less likely to make a mistake. So let's use our trick here and show that we do get the same thing. So it doesn't matter. I mean, it doesn't matter to me which one you use. So our trick says to first think of this as I know I'm stuttering. Sorry. Try to pick a color. This is my A minus B, my A plus B. All right, so the trick says I can do A squared, which would be square root of x plus 7 squared, minus B squared, where B is 3 squared. You can see already how this makes things a little bit easier. It's a bit less, a little less work and leaves less room for error. And now when I simplify, when I square the square root of x plus 7, I just get left with x plus 7. And when I do minus 3 squared, that's minus 9. Ah, so see how it really didn't matter? If you wanted to write out all the work for foiling, you definitely could, but you don't have to. You could just use this trick instead. And if you're in like a calculus course where you're kind of seeing, like this is going to be on a test or something like that, you may want to save time by using the trick. Okay, so notice now in this last step, we have met up in the same spot, whether we write out the foiling or whether we use the trick, doesn't matter. So let's merge them together now and just see where we're at. So we have the limit as x approaches 2. I have an x plus 7 minus 9, so that's x minus 2 in the top. And then I have an x squared minus 4 square root of x plus 7 plus 3. Now, sometimes at this point, I'll see what I can simplify in the top and bottom, but right now it's not totally clear to me. That means that I did have to do some extra work in the denominator. As I said, this isn't always the case. There may be a situation where like I have an x minus 2 in the top and I have an x minus 2 in the bottom just right away and I can simplify them. That's not what's happening right now. And so I look at the denominator and I say, okay, can anything be factored? And sure enough, we can factor this guy, and then that should fix our problems. So we have this limit as x approaches 2. I have an x minus 2 in the numerator. Now I can factor x squared minus 4 into x plus 2x minus 2. Notice that's actually just our trick worked backwards, funnily enough. All right. And now I say, hooray! If I can now get rid of this x minus 2 from the top and the bottom, now I'll no longer get 0 over 0 when I try to plug in 2. So I can simplify these. Now be careful. A lot of times when my students do this, they simplify out this x minus 2 and the x minus 2 and replace it with 0, like because you got rid of both of them. But that's not what's happening. When I simplify x minus 2 over x minus 2, it's because it's equal to 1. Right? When I get rid of, say, a over a, it's because this is the same thing as 1. And so I need to put a little 1 up here in the numerator, not a 0. Okay, it turns into a 1. Now I have my limit as x approaches 2 of 1 over x plus 2, and then square root of x plus 7 plus 3. And I feel now that it's safe to let x approach 2. I know I'm not going to get 0 in the numerator, right? I have a 1 there now. I kind of got rid of the issue that wasn't clear to us from the beginning. But now that I simplified that x minus 2 over x minus 2, we should be good to go. So now I'm going to try again. I'm going to let x approach 2. This time I'm going to write it in black because I know that we've done everything we need to. So I have my 1 in the numerator. Yes, and then I have a 2 plus 2 in the denominator, and then a square root of 2 plus 7 plus 3. It seems I found my answer, right? This isn't going to be indeterminate. We're going to get a nice actual value here. So I'll get a 4 when I do 2 plus 2, and then a 6 when I do, that'll be 3 plus 3. And so the limit is 1 over 24. One of the fun things you can do is just check to make sure that like your answer makes sense just using a calculator. You could find 1 over 24 as a decimal and then go back up to the original expression here. I'm going to erase here. So the original expression was this fella. And instead of plugging in 2, plug in something close to 2, like 1.999, something really close to 2. And you'll find that your answer is really close to 1 over 24. And so you can be like, seems that I found the correct limit.